Morning, everybody. I'm Luca Ruggero, EMEA Sales Director for DP Technology, the company that produced the software, the CAM software ESPRIT. We are here today for a new webinar, and we have today a new partner that joined us. That is YG1, a tool company that is growing very fast with new technology that will be presented today. We are here today to present you our partner, YG1, and also the way we think we can speed up your manufacturing process through high-speed turning. Today with us, we have Sascha Wenzel, Sales Director Germany for YG1, and Alexander Mokri. Good morning, Sascha. Good morning, Alexander.
Good morning, Luca.
Good morning.
Let me introduce shortly the agenda. We are here and we want to underline that the DP technology like YG1 is very committed to Industry 4.0, where Industry 4.0 have the main purpose to merge the hardware and the software. And it's why the YG1 hardware, the tool, is fitting perfectly with the software and the new toolpath that we are delivering through ESPRIT. So we will have an introduction from Sascha about the new technical center that is born in Germany, and then we can talk deeply about the new tool and how to work and to speed up your manufacturing process. We talk about this partnership. As I told you, Industry 4.0 is the main reason why really the hardware and the software are merging together to provide you a better solution. And then with Alexander, we'll see in details how it works the profit turning, and we can see a live session of the profit turning and how to program the right toolpath through ESPRIT. Let me just remind you a couple of things. In the tab you can find of GoToMeeting, you can post any kind of question. We try to collect all these questions and answer everything at the end of the webinar. In any case, if you have something in mind, some question after the webinar, you can send an email to YG1 and marketing@y-1.de and for ESPRIT marketing.europe@dptechnology.com. So I will move the mouse in this case in the presentation to Sascha. They will talk about the company and the new product they are delivering to the market.
Thank you, Luca. So give me a second.
Yep.
I will share my screen. Did you see my screen?
We cannot see your screen now. So now it's
okay.
Now you see the slides.
We see the pictures.
No, we see the camera
of the camera.
Okay.
Yeah, now it's, I think.
So now it should happen. I think now it's working. Yes.
Perfect, Sascha.
Thank you, everybody. Yeah, just a warm welcome from my side. I'm Sascha Wenzel. I'm the Sales Director of Germany, and I'm introducing the YG1 and especially the YG1 Technology Center in Germany, which is built now. At the moment, we are moving from our old facility to our new facility. And I start first of all with some key facts about YG1, where we come from. YG1 is the #1 end mill maker in the world. That means that we are producing more than 30 million pieces a year, 60 million drills in a year, tabs and indexable inserts. It's 36 million pieces. We deliver to 75 countries all over the world. We have more than 5,000 employees and more than 4,500 production machines in our facility all over the world. A few small overview. YG1 is the fastest growing company in the metalworking history. That means that we every year grow in very, very fast. Very interesting key fact is that we are built in 2015 a world-class manufacturing facility for indexable inserts, and we have a team for development that's more than 230 members, and we have also training labs all over the world. That means in Germany, especially in Oberkochen, and even in Russia, Italy, and something, and on different places. We are a total tooling solution provider. That means, as you can see on the left side, we are providing normally solid carbide end mills, tabs, drills, and also special custom-made products, which is very important at the moment because you have new parts, you get new advantages regarding manufacturing. We are working in diamond mold industry, in the automotive industry, aerospace, CRFP, electronics, and even medical. A big product line from our side is an indexable line. This is the reason why we are sitting together today and talking about profit turning. And yes, this is the whole product line that we provide, and even tool holding. Here on this slide, you can see our new facility. On the left side, you see the YG brand. This is the first facility that we are built here in Germany. It's a tech center. That means we are working high technology with the newest technology on the market. You can see on the left side some grinding machines. We have laser machines in the back. Sorry, that was my fault. And some grinding machines here. And in the middle, you see our academy where we're working together, even with DP technology, with ESPRIT. We have a demo area where we can test our new tools and the new applications from ESPRIT side, and we are still strong working together. Here's a small overview of what we're producing here in Germany. It's our PCD tools, some fine boring tools with motion controlled tools. We are very strong in PCD. We're working with the newest technology like laser and different others applications. The partnership. We have a very, very strong partnership between ESPRIT and YG1. We have a strong history. We are known, both companies known for innovative and unique solutions on the market. We always provide you the newest technology, and as a team, we are able to give you the whole package and close the gaps between the machine, the tools, and the software. Here's a small product overview. It's our V7 chip splitter. It's made even for profit milling. That means trahydral milling. Here you can see we are working with different materials like titanium, steel, stainless steel, and some cast iron. Here you can see we're working with premium tungsten carbide. We have special corner geometries, unequal index, and optimized chip splitters where you can rough and even finishing in one step. On the left side on the slide, you can see what is the normal chip of a conventional end mill and what is the chip of a V7 chip splitter. That means we have less problems with the chips, put the out of the machine, out of the material. We have less vibrations, and you can use this tool especially for profit milling. I now presenting some very, very nice tools. This tool is very unique on the market. It's a totally electronic boring bar, which you can control even via ESPRIT on the laptop, CAM software, or with this small remote control. It's used in the automotive industry, especially we have a project together with BMW. Here you can see on the right side of this tool, on the red, there is some batteries inside, and everything is controlled via Bluetooth over the software. You can measure in process, and you can adjust this fine boring bar in the process so that you get less scrap and have always the right tolerance for your products. How it works: you have a remote control. The remote control gives a signal to this boring bar. Here can you see the cassette, and the cassette is a little engine, electrical engine. The accuracy of this product is 0.001 millimeter. It's very, very fine, and the setting travel is 0.3 millimeters. And how we come together with ESPRIT: we have an interface where we can go directly from the machine into the process, and you can do this via ESPRIT. That means you make an NC event and program, and then the cassettes still going out and do this part, and especially finish this part. In the processes look like this. You have a process of machines. You have more machines. You measure your part, and then you give it to the gauthing process. You give it to the control, and the control gives it back to the PC, to the process. Now you can see the small boring bar here. It's in a bigger way. This is our drawings for the customers. Yes. And here you can see the measuring unit with a closed loop directly to the process. Let's talk about e-mobility. It's a specialty from the Technology Center in Germany. E-mobility is, everybody's spoken about this. This is the stator housing. It's very famous in the electromobility industry. It's used by Bosch, it's used by VW, on every car company who produce this. And we have special application. This is two applications for roughing, and this tool is modular, and it's made by aluminium and even by steel. And the benefits is why we are so high technology is that we are using a steel body, and we put in coating, an anti-vibration brush coating on it. That means we have less vibration in the process, because the hole that you have to manufacture is very, very big, and you have to look for your surface quality and even for less vibrations. This is a special holding for indexable inserts. It looks like a V, like YG. It's a two-point placed indexable insert. Normally on the market, it's just one holding. We have two holding with 55 degrees to get more precision for the finishing. Let's talk about profit turning. This is the reason why we're sitting together and where we're working together, strongly together with ESPRIT. Here you can see a small holder program, especially made for profit turning with internal coolant. Sorry, it was too fast. Special made for profit turning. We have internal coolant from the internal and even to the external cutting edges, that we can provide you a high cutting speed and a high feed rate to get more, to get less costs. Let's talk about a little bit over the technology, profit turning. Profit turning is so very impressive, because we are always working with radius, with the engagement radius, but Alexander will told you more. Than you can see on the right side the radius of the trochoidal radius and the sharp area and the regular passes area. So it's working very, very smooth. You have always a big chip control, which is a big benefit on this profit turning cycle from ESPRIT. And as you can see, the tool life could be 3 times more. You have less cost on your parts and less cost on your tools. Here is an application report. We're working with a cutting data of 400 meters. It could be a brake disc or something else. As you can see here, we have trochoidal passes always here. We have the engagement, which has come inside together with our tool holding. And now, this is a special, only a special promotion for the guys who enjoy our meeting today. We are providing you 3 inserts and 1 profit holder. That means you buy 30 inserts and get 1 profit turning holder from ESPRIT and from YG for free, and you can use it, and we can work together on your technology. And if you're interested, you can send an email to info@yg1-techcenter.de to buy it or asking for some support regarding these tools. Yeah, that was from my side. I will give the word to Alexander, who is showing us the profit turning cycle in ESPRIT.
That's right, Sasha. Thank you for your introduction. I try to share my screen. Sure. So can you see my correct screen now?
Now we can see.
Presentation.
Yes, we can see it.
Okay, thank you. So Sasha already talked a lot about this new tool, as we can see it here in the picture. It's a new partnership that has been coming into place with ESPRIT and YG1. Focusing today, we will be looking especially at this tool and how to program it within ESPRIT. What are the benefits for you as our customers, and how are the proper processes for this tool are applied within ESPRIT? And yeah, we call it profit turning cycles. We will have a look at it later. Sasha already mentioned a bit of it, and we will dive a little deeper in the technical part of this kind of tool passes and strategies. Okay, the agenda from my side today will be YG1 and ESPRIT for first point, a quick point, and then we will have a look at the technical part. After that, we will swap to a live presentation within the ESPRIT interface, and then questions and answers round. All right, first point of today, YG1 and ESPRIT. So we're talking about a very close partnership. Sasha already mentioned it. These tools are YG1 certified, and they are developed for and with ESPRIT processes. So this is a very strong combination between tool and software. Your advantage is, of course, technological competence for your support regarding feeds and speeds. These processes are approved. The feeds and speeds are provided by YG1 and in combination with ESPRIT's strategies. We can apply very modern, very highly efficient strategies, profit turning strategies, very easily within the software. Okay, profit turning, a little technical overview. How do the tool passes work, and what benefits do you have by applying them? For this, we watch a short video first. In this video, you can see we will have a look a bit closer on this tool path. So you can see as it's alternating its directions, but then also doing it smoothly. And furthermore, it's not only doing alternating directions, but also changing the feed rate by entering the cut. So wherever usually the highest load is to be expected, the highest forces, we are reducing the feed rate. The customer can control in what amount it is to be reduced. And this is so this smooth rolling in and out and this reduced feed rates are what extends the tool life dramatically. There's a lot of mathematics behind these processes. They can be altered to your needs and are very versatile to be used. So this part we just saw in the simulation, it's now the real cutting situation. On the left side, we see the profit turning compared to a conventional process of zigzag grooving. So it's a massive time reduction and yeah, very efficient process. Very good for the tool life.
And Alex, what you can see is that you always have the chip control, like you say, with a small radius. You can use the whole indexable insert, and because of the chip splitter geometry on this indexable insert, you will always have some chip controlling, and you see it on the right side, there's less chip control. On the left side, there's always a chip control. That means you are not have any problems with spinning chips and something else.
That's absolutely right. Yeah, Sasha, especially on hard material and material that tends to cause problems on chip breaking, these kind of processes and these kind of tools are very, very beneficial. Of course, YG1 offers other tooling as well for other applications for where we can use profit turning as well. We will show this on the next pictures. So these are some typical applications. High advantages come usually where we have trouble, where the tools tend to vibrate on conventional approaches, where we have, for example, like we see here, these deep grooving passes, where we have tricky to reach areas for machining. This is being approached with very high feed rates, but small cut-off depths, so depth of cut. So the forces are dramatically reduced with the smooth rolling in and out. The chips break properly, even in tough areas, and the material removal rate is increased overall. So it's only advantages to use these kind of strategies. Another short video about other applications. For example, of course, you can use it on phasing operations. You can use it on base grooving operations as well. And yeah, next example will be an internal toolpath. There's a bit of, please ignore it on the left side. We will have a look at this later. So this is about the internal application. This is a good example for a tool that is quite long, and it would usually cause problems here. It will vibrate and make troubles machining this part. So this sorts of tool passes are very good to use. We have a look at it in the simulation as well. So it's keeping the whole process smooth and under control, even though the circumstances are not the best in this situation. Also, I've been talking about alternating cut directions. You are, of course, not forced to do it. In this case, we are just pulling out so for the chip evacuation. As a rule of thumb, I think the feeds and speeds you can increase them. You can increase the cutting speed by 2.5 times faster, and you can increase the feed rate 3 times than what you would use on a conventional approach. Okay, let's swap to the live presentation. We will have a look at profit turning processes in ESPRIT and how they are applied with this tool and the settings that we have inside the process. I will now swap to the ESPRIT interface. So I hope everyone can see this now. Is it correct?
Yeah.
All right. So what we have here, what we find here is a prepared CAM workspace. That's how you would work with it usually. It's a template. We have a machine already loaded. We have our workpiece already loaded, and we have some of the tooling prepared. The YG1 tool is loaded here and ready for us to use. What we will do now is have a look at this part. So this is just a sample part to apply some of the strategies. We will only focus on this YG1 tool now and for the roughing processes that are involved. So highlighted in orange are the areas to be machined as I select them. And we will now apply process on these areas. But this is quite easy to be done. You only select your machining area and then your appropriate process. As we already suggest the correct tool. The feed rate, the cutting speed is very high. It's 400 in this example. It's for 4140 steel, but Sasha and YG1 do provide a spreadsheet for these kinds of cutting data for this tool. So this is an example, 4140 steel. We are running 0.7 per revolution. For strategy, we of course apply profit turning. We have all the necessary settings here, like the step over, the cutting depth. We have the roll in and roll out radius. We can control how the cut will be entered. We can control the roll in, roll out feed rate. We reduce it to 80% in this example. And we can also define the minimal radius that is allowed to be generated in this toolpath. So with only one click, we have done this whole toolpath here. Let's have a look at the simulation. And here, again, you can see it. It's a very smooth process, and we are constantly producing chips here. We are always in the cut. The load is the same on the left side of the blade as on the right side. So it's a smooth way to wear this tool off. It will last much longer and be much more efficient to get the material removed on this way. If you would like to use
Alex, especially I see this always from the market, especially when you have low power machines because they have not so many torque. You can't work with CNM or DNMG with 6 millimeters. It's a very nice application to work on less power machines, on smaller turning machines to generate a lot of chip and removal rate. So
exactly.
This application is very excellent for this kind of machines when you have smaller machines, but you have to take a lot of chips out of it, material out of this.
That's right. The whole idea behind this process is to reduce the forces and to make sure that the cutting forces are low. So it lends itself to, as you just said, those kind of machines. It's very, very beneficial to use this. Yeah, yes, that's right. So I would like to show how to apply this process. So we already programmed this here on the right side. So all you need to do is to drag and drop it onto your next chain as you wish to machine it. So you don't have to worry about it to fill in all this whole mask again. Just drag and drop it, it's 2 clicks and the process is ready to go again. And we are machining here. Same settings than before. Okay, some alterations on this program. I would like to support it here on this side with the sub spindle. So this is very easy to be done as well. Just put insert location and we park the tool and we pick up. So I will do this a bit fast now, but we will have a look at it together quickly in the simulation. So what I have changed now is just that we grab part. We have a collision here, so there's a mistake. So this is why we have this digital twin, that we see these sorts of things happening before they are happening on the machine. So this is a little mistake. I was playing with this program before the presentation, so I think it's only has to be set to 0 here, and then it will work again. So it will work.
Perfect.
And machine this part. Okay, let's have a look at these grooves. So we see we have 2 grooves here. One that is a bit easier to machine, allows us a better chip removal, and one that is a bit harder. It has a steep wall and it's getting smaller here. We will have a look at this easy groove first. Same as before, just select it, and we go into the turning features here and select the grooving operation. We have, of course, options. Imagine, for example, we have the chuck grabbing here. So we can just swap this tool. ESPRIT will then automatically calculate the spindle direction to match the new situation. So it's easily swapped. so we have enough clearance here. The strategies are the same than we used before. For the OD roughing, we have a step over that we can define, a cutting depth. We have the roll in, roll out radius, the feed rate to be reduced by rolling in, and the minimal radius that is allowed to be calculated in this pass. And it's a click, and we have done it. And also the second groove, we can just drag and drop it. We've done it here as well. So we think we can do this one a bit tougher. And 0.8. So this is this first groove, and we have a look at the other one. We do this a bit smoother with only 8% engagement, but therefore we increase the feed rate to compensate this and still have the long tool life and all the other advantages. So you see, smooth rolling in, smooth rolling out. No matter what you machine, if you are roughing on the OD, if you're doing a groove, if you're doing a facing operation or internal, it's always the same process, always the same tool path and the same mask that you just saw. Just draw back and show you the mask again. So it's always the same mask and the same settings, no matter where you are machining. So it's quite easy to understand and to apply. Okay, let's do the parting as the last step. We have now been roughing this whole part, and we are doing the parting operation. Also very easy, just we select the cutoff, and we are parting. Okay.
Perfect. I have one question regarding the machine.
Yeah.
So what happened if we don't have a MATSEC? Maybe we have a different machine like DNMG, or how long it takes to put all the processes together to change the machine?
I think I will just show it on an example. Yes, it's right. We have a MATSEC here, and everything is loaded here, and we have programmed something. And yeah, maybe it can be the case that a machine breaks down also, and you need to go to another one. If the customer, for example, he has another machine, DMG Mori, for example, then we are able to swap this quite easily.
Okay.
Let's have a quick look at this in C code for this machine. So we have a MATSEC in C code. Everyone can see it, I think, for this program. And we are swapping this machine now to this DMG Mori. Got the same kinematic, but of course some other travel limits and so on within this machine. So I'm loading this machine. You see we are still in the same ESPRIT document. We just swapped the machine. And what makes this possible is the machine intelligence that is behind every machine package that is coming with ESPRIT. So we are talking about digital machine packages here. It allows us to swap machines because this intelligence behind it always calculates everything new. So as soon as you swap the machine and you hit the OK button, the whole program will adapt to the new situation. You see, we just swapped the machine. We have a completely new program. And what we just saw before, we will see the exactly same simulation again, only on another machine with another G code and another kinematic. But this makes it quite versatile. You only in real, you just would swap your tool to the other machine. You set your 0 new, and then you are ready to go with the new machine as well. Let's have a look at this in C code. Will be another one now. In this case, a Siemens for DMG Mori.
You change from different controls. I think it was less than 3 seconds, yeah? Just
Yeah, if you just select the machine, change it, verify the simulation again, check it, the digital twin. We saw a little collision in the beginning, those sorts of things, and then you're ready to post the new code and go on your new machine, on your other machine.
Perfect. Very fast.
Yeah, I just want to underline that both for Mazak and DMG Mori, we have a strong partnership together, like with YG1. So we're developing the post-processor directly with them. It means that the post-processor they are giving to the market are certified directly by the machine tool builder. So the quality of G code it's really nice.
Yeah, and I think this is the very important thing to understand. It's not only the CAM software, it's not only the tool, not only the machine, it's always the combination. It has to be perfect to get the perfect results. And that's why we have these kind of partnerships. And also this presentation today is just to be focusing on this profit turning processes and to make you, the customers, aware they are existing. They are here to help you getting things done faster and more efficient in the future. Yeah, so I think this was my presentation from ESPRIT. I will just swap back to the PowerPoint. And as promised for the agenda, we have now the little questions round where you can ask questions. And please also feel free to contact these emails for YG1 and for ESPRIT as well. Okay, thank you.
I have one question to Luca. Luca, how we can give the benefit to the customer, how we work together?
Yeah, we have a special initiative with YG1, and we'll be very happy to prove the validity and the quality of the solution. It means the tool from YG1 and ESPRIT directly in your facility. So if you're interested to understand how you can boost the processes, how you can save time and money, I think we have an interesting solution, and we are really ready to do a live test on your machine in your facility. So please, if you're interested in these things, just contact us or YG1, me or Sasha, and we will organize a test cut for you.
Perfect.
And I have a couple of questions coming from the people. And Sasha, there was a slide where we talk about 3 times the lifetime of the tool, and also that you can save a lot of time in terms of cutting. You can quantify also the time of cutting that you can save, because 3 times the life of the tool, it's already very interesting. But it's also how much you can speed up with your tool and the profit turning.
Like Alexander say, in the feed rate and speed rate, we are 2.5 more feed rate and 3 times more speed rate, sorry, and 3 times feed rate. Cause of the chip control, and we have always the same chip thickness, and we're working with the geometry of the indexable insert. We go in directly into the chip breaker. That makes this is the reason why we can improve our feed and speed rates so high, and it's less cutting forces, like Alexander also say, and so we have less cutting forces. And when you have a good substrate with a good coating that need a little bit heat, then you can very high speed turning, like profit turning on this machine. This is a benefit. This is the benefit of the cycle. You can't only trochile milling, yes.
That's great. And Sasha, another question was, you can apply this technology on every material? So it's working okay from aluminum to titanium, or there is a specific material that...
No. This is a good question. Like Alexander also say, we can also provide an indexable insert with a CBN flank on it for hardening, for hardened steel. So you have the less problems with hardened material, and especially for titanium, inconel, and ductile material, where you have some problems with chip breaking, like aluminium with the long chips. You don't have the problem with this profit turning process, because changing direction, you always working with the chip break on the indexable insert. And even when you have in the medical industry some plastic solutions for hips or knees, when you turn that, you always get long chips. And when you use the profit turning cycle, then you does not have the problem, because you swap and zigzag from left side to right side, and you always have chip control. And like also in the titanium industry and aerospace, it's very, very, very good, because you have less cutting forces, you don't make anything with the material, and you have high removal rates. So you change only the indexable insert for titanium or for cast iron, and you can work on every product, on every material which is on the market. And then it only depends on the speeds and feeds. You don't work in Inconel with 400 meters without some ceramic.
Of course.
Without some ceramic, but we even provide ceramic insert for this. So as you can see, we have some coolant from the top. We have coolant from downside. So that makes it very efficiency, and you can always put also some air into the holding system when you want to work dry. It depends on the material, if you have plastic or if you have titanium or normal stainless steel or steel. It depends if you want to work with coolant or only with air or MQL.
Okay, wonderful. And another thing that you mentioned that I think we should underline again is that it's very important that this tool and this technology, it's working also with light machine. Am I right? Without, not so powerful, not so strong, with not so much torque. So you don't need it with profit turning and your tool, right?
Yes, you can work with the machines with less torque. The problems on the market in the past, you have bigger machines with a strong engine and with a gearbox inside, and now you have linear engines. That means they are very speedful, because they change in the speeds from high to low or in a different direction. And when you have smaller machines, but you have to produce some parts which have a lot of chip removal, a lot of material that you have to turn off, then it's very, very, very efficiency when you're working with this profit turning. Yes, because you don't need so many forces. You will see it directly when you work with this in your facility. You have less cutting forces. You hear this on the machine, and you see the load on the spindle load. It's less than 30%. Yeah.
Perfect. And also, because you have less chip removal, you decrease also the vibration on the machine and on the part. So the surface quality, it's have some changes in terms of surface quality with this technology.
It's also so that the roughing, we're talking about roughing, not finishing.
Yeah, sure.
The roughing surface is very, very smooth, and you have always the same measurement. You have always 0.1 or 0.2 on every geometry on your part. That means when you go into the finishing, you don't have so many problems, even with the chips at finishing, because you are next to the geometry, and we have a very, very nice roughing surface.
Yeah,
Sometimes,
because we saw some example from Alexander about the grooving. And you know that with your technology, typically you have the big step that sometimes can break your insert or can create some kind of damage on the surface.
Yes.
So profit turning should create, a very smooth surface and also preparing the part for the finishing.
Yes. Yes. Absolutely.
Perfect. I don't have any other question in my list. So thank you very much for this webinar, Sasha. Thank you for giving us the knowledge, and we are very proud to work with YG1, and we'll be more than happy if there is some opportunity to work directly together with the customer. So if you have any kind of opportunity as customer to see the advantages that we can bring with ESPRIT and YG1, just call us. Here you can find the email, and we hope to see you soon directly in your facility. Thank you, Sasha.
Yes.
Thank you, Alexander.
Thanks, Alexander.
Thank you.
Thank you, Luca. Thank you.
Have a great day. Bye.
Bye-bye.